All right, hey chemistry students, we are going to look at solving a process where we figure out the energy, the total energy of a reaction. And we're going to look at the energy of the products minus the energy of the reactants. So remember the left side of the equation is the reactants, the right side are the products. Okay, so we're going to use the same process that we've been using to figure out energy in the last couple class periods, but we're going to combine it together to figure out what's the energy of each of the individual elements. Okay, so one little note on this before we start going on this. If you look at the note here, so only atoms and alpha particles have binding energies. So anything that is a beta particle like this or a neutron did not have binding energy, so we don't include that as part of it. Okay, but any of the elements or atoms, and if we had an alpha particle there, we would include them. Okay, so we're going to again repeat the same process that we did in the last couple class periods, and we're going to just do it for each side of the equation. So we're going to start with helium, and we're going to look at first we're going to find the mass defect of helium. Okay, so if you remember the equation that we just had, if you look at the previous page, okay, we have the first thing we start with is the mass of the nucleus of the atom, which is, in this case, 4.003 AMU. Okay, so we're going to use that as our mass, minus, we have the little brackets, the number of protons that helium has. And if you look up helium on the periodic table, it has 2 protons, times the mass of 1 proton, which is 1.007 AMU. Okay, we're going to add that to the number of neutrons for helium. And so if we have 2 protons, the mass number is 4. We know we're going to have 2 neutrons, and we're going to multiply that by the mass of a neutron. So we're going to figure out the number there. We'll punch it into our calculator, and what we get is, the bell's going off, negative 0.027 AMU. So there's the mass defect in AMU. And then remember, we need to multiply that by our conversion to kilograms. And my total value here for mass defect in kilograms would be 4.482 times 10 to the negative 29th kilograms. Okay? And we'll keep that as a negative answer there. So there is my answer. Okay. Then, if you remember, when we try to figure out the binding energy, we use Einstein's equation, equals mc squared. We're going to take the mass from here, and it's going to be written over here. So my mass is negative 4.482 times 10 to the negative 29th kilograms. And I'm going to multiply that by the speed of light, 3 times 10 to the 8th, and that value is squared. And when I do that, what I get is negative 4.0338 times 10 to the negative 12th joules. So there's my binding energy for an atom of helium in this case. Okay, now here's one little new thing, is if you look at my equation here, I actually have 4 of those. So I have 4 atoms, or 4 moles of this. All right, so we need to make sure we multiply this by 4. So we're going to multiply this value by 4 because I have actually 4 atoms on that side. Okay, and when I do that, I get an answer of negative 1.61 times 10 to the negative 11th joules. Okay, so there's my binding energy for the left side of the equation. All right. then I need to take into account what's going on with carbon. Now, we made a little bit of a mistake in that we didn't write down the actual mass of carbon, so I'm going to give you that. You can just get that from the periodic table. And the mass is 12.011 AMU. Okay, so we need to go through and do the same process with carbon. So we have the actual mass, 12.011, minus carbon, if you look on the periodic table, has 6 protons. We'll multiply that by the mass of 1 proton. And then I'm going to add that to, if it's carbon 12 and I have 6 protons, I have 6 neutrons. And again, the mass of that is 1.008. And again, those are constant values. Okay? So when I do that and calculate that, I get negative 0.079 AMU. And then I'm going to multiply that by my 1.66 times 10 to the negative 27th kilograms. And I get an answer there of negative 1.311 times 10 to the negative 28th kilograms. We're going to use that number over here, and we're going to take that number, negative 1.311 times 10 to the negative 28th, and then we're going to multiply that by the speed of light squared. Okay, and when we do that, we get negative 1.18 times 10 to the negative 11th. Joules. So there's my binding energy for that. Okay. All right, so we have our binding energy for helium. We have our binding energy for carbon. So now, according to what we have up here, we're just going to take the difference of those two. Okay. So energy of the products. So the products are on this side. We got negative 1.18 times 10 to the negative 11th, right, because carbon's on the product side. Okay, and we're going to subtract that from, I'll do a little parentheses here, negative 1.61 times 10 to the negative 11th. This is joules, and this is joules. Okay. So, when we do that, oops, let me see that. Slide that up again. Sorry about that. Okay, so I have the mass from here. The energy from here, and the energy of the products and the reactants. Okay, so the final answer there, when we do that, if we do, I'll show you my calculator here. We're going to do negative 1.18 to the negative 11th minus, I'm going to do in parentheses here, minus 1.61 negative 11th, and we get 4.3 times 10 to the negative, or 10 to the 12th, I'm sorry, 10 to the 12th. And that would be joules. Okay. 4.3 times 10 to the 12 joules. Okay. Now, that is per atom. We want to figure out the energy per mole. So remember, the conversion there from atoms to moles is that 4.3 times 10 to the 12th joules per atom. We're going to multiply that value by 6.02 times 10 to the 23rd, because that's how many atoms are in a mole. And when we do that, yeah, this is negative, by the way. When we do that, we get 2.59 times 10 to the 12th joules. There's our final answer. Okay. Whew. So that's a lot, right? So we did. Figured out the mass defect, figured out the energy for helium. We had to multiply it by 4 because there was 4 of those. We figured out the mass defect of carbon. We figured out the energy for carbon. All right, there's only one carbon atom. We subtract those two numbers, and we get 4.3 times 10 to the negative 12th. And then I multiplied that to get the final answer, to get the number of joules per mole by the 6.02 times 10 to the 23rd. Okay? So, there's a couple more practices like that. Again, on the front side of the worksheet, okay, it gives you all the numbers. It'll give you the mass defect equation, the masses for the different protons and neutrons. It gives you the equation for the energy as well. Okay? So, hopefully that helps. We'll talk to you later. See ya.